Hello dear students, good evening. Uh, Today we are going to have our third session on linear programming problems. Now before I start, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students?
Yes.
Okay, great. So if you recall the last session, at the end of the last session, that is the second session, I informed there are different types of linear programming problems, and this is the slide what actually I showed at the last of the sessions 2. So I start from this slide. So there are mainly 4 categories of problem which generally comes under linear programming problem, which you need to solve graphically. And also one thing you will notice that in your board examination the problem will come from actually around this area. Either it could be a manufacturing problem, or it is a diet problem, or it is a transportation problem, or it is an allocation problem. So as you see in the screen, in the manufacturing problem, what we generally address is that in these problems we determine the number of units of different products which should be produced and sold by a firm when each product required a fixed manpower, machine hours, labor hour per units of product, warehouse space per unit of the output, etc., in order to make the maximum profit. So these are the constraints. What are the constraints? The manpower is a constraint, machine hour is a constraint, labor hour is a constraint, okay, and also warehouse space, that is also a constraint, and subject to those constraints we need to maximize our profit. So that is a problem related to manufacturing. Next one is a problem that is related to diet problem. What is that? In these problems we determine the amount of different kinds of constituents or nutrients, right, which should be included in a diet so as to minimize the cost of the desired diet, okay, such that it contains a certain minimum amount of these nutrients or constituent. We will see one problem. Next one is the transportation problem. In this kind of problems, we determined a transportation schedule in order to find the cheapest way of transporting a product from a plant or factories situated at a different locations to the different markets. And next one is the allocation problem. In these problems, we determine allocation of resources, for example land, in order to find the maximum production of crops with least usage of pesticides. So whatever you see in all these problems, these are all optimization problem. In case of manufacturing problem, okay, that the optimization is the profit maximization. In case of diet problem, you see we need to minimize the cost of the diet. In case of transportation problem, we need to minimize the travel cost. And in the allocation problem, okay, that we need to use the different resources to least usage of the pesticides, okay. And all these optimization problem based on some underlying constraints. For example, in the manufacturing problem, the constraints, as I said a minute back, are the manpower constraint, machine hour constraint, labor hour constraint, warehouse space constraint. In case of diet problem, the constraints are that a constraint of having a particular nutrients or constituents, okay. In case of transportation problem, okay, the constraint are the different mode of transport and their maximum cost what we can afford. In allocation problem, the constraint is that what is the usage of pesticide, okay, that is a constraint, that is the maximum we can use that pesticide, okay. So let us now discuss with the first problem, that is a diet problem that we are going to discuss, okay. Please open your notebook okay, so that when I am explaining that problem, you also do along with me. Okay, if you understand few problems properly, all is needed is practice after that, and it will be absolutely clear. Okay, and also, as I always say, in case you have any question during the learning, then you can always ask me. Stop me, make your understanding clear, and then we will proceed. Okay, so the underlined diagram is not showing properly, but anyway I will explain it here. So what is a diet problem? A dietitian wishes to, let me first read out the problem. A dietitian wishes to mix two types of foods in such a way that vitamin contents of the mixture contain at least 8 units of vitamin A. So that means the first constraint is that vitamin A, I am writing it here, vitamin A should be at least 10 units, okay, sorry, 8 units of vitamin A. So that means vitamin A should be greater than equal to 8 units, and vitamin C 10 units. So vitamin C should be more than 10, greater than equal to 10. Now food I contains 2 units per kg of vitamin A and 1 unit per kg of vitamin C. Sure, let me write it down. So what is that? Food I. So what it is having? It is having vitamin A 2 units per kg. So vitamin A, it is 2 units per kg. 2 units per kg, and vitamin C, that is having 1 unit per kg. Correct? And food 2, that is the second one, let me go through it and write it down, go through the problem. Food 2 contains 1 unit per kg of vitamin A. So in food 2, if we see, the vitamin A is actually 1 unit. Food 2, let me read out where it is. Food 2 contains 1 unit per kg of vitamin A. So 1 unit per kg of vitamin A and 2 units per kg of vitamin C. So it is 2 units per kg. Okay. It cost rupees 50 per kg to purchase food 1. So it is rupees 50 per kg and rupees 70 per kg to purchase food 2. That is rupees 70 per kg for food 2. Now what is that question here? Formulate this problem as a linear programming problem to minimize the cost of such a mixture, because the entire diet is actually having the mixture of the food 1 and food 2, so that it can it contains the bare minimum requirement of vitamin A and vitamin C. So let us assume that x kg of food 1 and y kg of food 2 is procured. So here we are assuming x kg of food 1 and y kg of food 2 is required. Correct? Then what will be the cost of the entire mixture? It will be 50x plus 70y. Why 50x? Because for food 1 the cost per kg is 50 rupees. So there is a x kg, so it will be 50x. Similarly, for food 2, it is rupees 70 per kg. For y kg, it is 70y. So, what we need to find? We need to minimize, because that is the cost, right? Objective function, if you recall. So, minimize z is equal to 50x plus 70y. That we need to minimize. Now, what are the subject to the condition? So, that we are going to find it out. Subject to the constraints or condition, whatever. What is the first constraint? First constraint is that the vitamin A requirement is at least 8 units per 8 units. Vitamin A should be 8 units minimum. Now, per kg of food 1, the vitamin available is 2 units. For x kg, it will be 2x. So, 2x units of vitamin coming from food 1 and y unit is coming from food 2, because food 2 contains 1 unit per kg of vitamin A. So, 2y plus y, that should be greater than equal to 8, because the minimum requirement is 8 units, correct. Now, the second one is that, let us come to vitamin C. In the similar manner, it will be x plus 2y is greater than equal to 10, and there are obviously non-negative constants, that is x greater than equal to 0 and y greater than equal to 0, because you cannot purchase negative kilogram of food, it is impossible, right? That is why it should be greater than equal to. So, that is the formulation of this problem as a linear programming problem. So, what is the first question is that formulate this problem as a linear programming problem. So, whatever we have done, that is in the blue color, whatever, let me mark it here, okay. So, this is the formulation of the problem as a linear programming problem, and then we need to solve it. Okay. So, how to solve it? Let us do it. Okay. So, to solve it, dear students, so let me take it here. So, we need to draw the graphical representation of these straight lines. So, though it is 2x plus y greater than equal to 8, we will consider 2x plus y equal to 8, and we will take the right hand side for as it is greater than equal to 8. So, let me draw this one. So, let me draw this graphical representation. So, this is positive direction y axis, x axis and origin. So, I am not considering the negative direction of x and y axis, because they are out of context, they cannot be negative. The first one, what is that? 2x plus y greater than equal to 8. So, from here what you will do? It is 2x plus y equal to 8, and I always prefer that you can represent that straight line in the intercept form. That means it is x by 4 plus y by 8 equal to 1. So, what you will do? So, this is 1, 2, 3, 4, 5, 6, 7, 8. Let me write it down. 1, 2, 3, 4, 5, 6, 7, 8. And then in the along the y axis also, let us keep it. Okay. Here 1, 2, 3, 4, 5, 6, 7, 8, like this. The first one is that x by 4 plus y by 8 equal to 1. So, this is the 1, x by 4, 4 is the x intercept, and y8 is the y intercept. So, we will join these two. So, let me join using the suppose in the blue color, and this is the one. This is the one which is 2x plus y equal to 8. Now, in the constraint it is 2x plus y greater than equal to 8. That means what? That means we will consider all the right hand side portion, right? So, right hand side portion we will consider, because greater than equal to 8. So, this portion we will consider. Next one is that x plus 2y is greater than equal to 10. So, let me use a green color here. So, x plus 2y greater than equal to 10, x plus 2y greater than equal to 10. So, in straight line you will write equal to 10. So, if you replace, if you express this in the intercept form, it is implying x by 10 plus y by 5 equal to 1. So, we need to make x 10. So, 8 is there. So, 9 and 10. So, x by 10 is this one. So, let me mark it, and y by 5 is this one. So, let us join and let me represent in the blue color, in green color. So, this will be the straight line, correct, and here also it is greater than equal to 10. So, that means we will consider the right hand side portion, correct. This is the portion we are going to consider. And the next constraint is that it is x greater than equal to 0 and y greater than equal to 0, correct. So, what we see, dear students, is that we get a region, the feasible region. So, let me mark in the feasible region in the black color, where the green and the blue lines are actually superimposed. That region we are going to consider. So, what it will be? It will be this portion actually, whatever I am marking in the black one. Okay. So, this region will be the one. So, and this portion also the green color will come. How come? Because if we extend this straight line, so what I am saying is that if you extend this straight line, though it is negative side is not required, but when you make, let me do one thing, let me do it in the green color. So, what I wanted to say, that if we extend that line and then we need to consider the right side, na? So, then you see that when both x and y greater than 0, so this portion is also coming. So, now go back to, let me go back to find the feasible region. So, this is the feasible region, whatever I am marking in the black color. So, that is the feasible region, and it is an unbounded region. Okay. So, that is why some special case has to be organized here. So, what are the points where what we are getting here, dear students? So, suppose this is the point A, and this point A is having coordinates 10, 0. Then this is the point B, suppose, and this point B is having coordinates 0, 8. Next one, this is the point C, which is the intersection of these two straight lines, 2x plus y equal to 8 and x plus 2y equal to 10. So, if you solve it, you will find the coordinates of this point C is 2, 4. I am not spending time to solve these two linear equations. This is quite basic. Okay. Now, according to the corner point method, we need to find the value of the objective function. So, what is the objective function? That is 50x plus 70y. We need to find the value of this objective function 50x plus 70y for all these 3 points. A means when x equal to 10, y equal to 0, for B when x equal to 0, y equal to 8, and C where x equal to 2 and y equal to 4. So, let us find it out. So, what we get here is that, so let me write it down. Okay, so here are the corner points. And here is the value of the objective function z equal to 50x plus 70y. Now what is the first point? First point A, that is 10 comma 0. 10 comma 0, that means when x is equal to 10 and y equal to 0, and here we get the value of z, that is 50x plus 70y, that will be 50 into 10 plus 70 into 0, that is 500. So we got it, the first one. Next one is that for the point B. For the point B, what is the coordinates of the point B? That is 0 comma 8. Now at this point, what is the value of z? 50 into 0 plus 70 into 8, so that is 560. Okay. And now let's come to the point C, and the point C is that coordinates of the point C is 2 comma 4, that means x is equal to 2 and y equal to 4, and when x equal to 2 and y equal to 4, the value of the expression 50x plus 70y becomes 50 into 2 plus 70 into 4. That becomes 50 into 2 is 100 plus 70 into 4 is 280. So 100 plus 280, that is equal to 380. Now what is our objective? Our objective is to find the minimum value of z. Now out of all these three, 500, 560 and 380, we see the least value is 380. Okay, so that is the least value, but whether it is a minimum value or not, that we need to investigate little further. Why? Because the feasible region is not bounded. If the physical region is bounded, then no problem, 380 is become the minimum value. Okay, but as feasible region is not bounded, what we need to do? We need to do something extra. And what is that something extra? For that, we need to bring that another inequality, that is 50x plus 70y. So what we get is that 50x, that is objective function, so I am writing it here, 50x plus 70y, that should be less than the least value what we get, 380. Now if we simplify that 50x plus 70y less than 380, that become 5x plus 7y is less than 38. Now we need to plot that one as well, and if we plot, so it will be something be a line something like this. So let me plot it here. It will be something like this, and it is less than 38, so it will be this portion less than. Okay, now we need to see that whether there is any common plane on the feasible region with this one. There is no such common plane, so what you need to find, and this region whatever I have just drawn, okay, that is not common with the feasible region. We already found it out, which is in the right hand side. So that means what? As there is no common point, what we can say is that we can say yes, the least value is the minimum value. Now if there exist common points, then we can say no, the least value cannot be the minimum value. But here in this case we can say this is the minimum value. Okay, so that is this special case is when the feasible region is not a bounded region. If feasible region is a bounded region, then this exercise, the last one, whatever I said, that 50x plus 70y less than 380 from the objective function expression, that exercise is not required if the feasible region is a bounded region. Okay, so we got it. So now let's proceed to the next question. Okay, I take time and explain this problem so that you get a very clear picture exactly how to solve it. Okay. Next one. Next one, let's go. It is an allocation problem. Okay. Just give me a second. Okay, so let me first go through the problem first. A cooperative society of farmers has 50 hectares of land to grow two crops, X and Y. Okay, so there are two crops, X and Y. Now, this is a first statement. The profit from the crop X and Y per hectare are estimated rupees 10,500 and rupees 9,000 respectively. Okay. So if I write the profit, let me use blue color. So first we write the profit. So profit from crop X and crop Y. For crop X it is rupees 10,500, rupees 10,500 per hectare. Okay. And for Y, so let me write it down, per hectare. And for the crop Y, it is rupees 9,000 per hectare. Rupees 9,000, just a minute, 9,000, let me write properly, dear students, 9,000 per hectare. That is the first point. Okay. To control weeds, a liquid herbicide has to be used for crop X and Y at the rate of 20 liter and 10 liter per hectare. So, per hectare. So, for crop X, the herbicide is 20 liter per hectare. So, I am writing it here. For herbicide, so let me write it down here. Let me use a different color. Herbicide. As I read this question, and I am writing it in a tree structure so that it is easy to understand what is exactly meant for. It is 20 liter per hectare. This is a constant. 20 liter per hectare. And for crop Y, it is actually 10 liter per hectare. Okay. Further, no more than 800 liters of herbicide should be used in order to protect the fish and wildlife. So that is a restriction. So herbicide can be maximum of 800 liters. So I can write it down here. So herbicide should be less than equal to 800 liters. That is a constraint. Okay. And at the very beginning, it was mentioned a cooperative society of farmer has 50 hectares of land. That means the restrictions on the land is 50 hectares. So land should be used less than 50 hectares, correct? That is also a constant. Okay. How much land should be allocated? What is the question? How much land should be allocated to each crop so as to maximize the total profit of the society? Okay. So we are going to form the equation, that linear programming problem, but before that let me read out the question once more. Okay. So what is the question? A cooperative society of farmers has 50 acres of land. So that's why I read that land is less than equal to 50. To grow two crops X and Y, the profit from crop X and Y per hectare are estimated as rupees 10,500 and rupees 9,000 respectively. Whatever we have written here. Okay. Next one is that to control weeds, a liquid herbicide has to be used to crop X and Y at rates to rupees 20 per rupees 20 liter and 10 liters per hectare. So that is a restriction here. That is not a restriction. That is a requirement here. To control weeds, that 20 liters per hectare is to be for crop X and 10 liter per hectare for the crop Y. But the restriction is that maximum usage of the herbicide. So further, no more than 800 liters of herbicide should be used in order to protect fish and wildlife using a pond which collects drainage from this land. Okay, so that the herbicide this drains from the land to the to the land. From the land it is actually a drainage to the wildlife, so the fish and wildlife should be protected. Okay. From the drain of the land it actually goes to this wildlife. So that's why that herbicide can be used maximum of 800 liters. Now whether we are going to use for crop X or crop Y or both, whatever it is, herbicide restriction is 800 liters. So this is a constraint. Now the question is that how much land should be allocated to each crop so as to maximize the total profit to the society, profit of the society. So let's assume that X hectare of land to be given to crop X and Y hectare of land to be given to be used for crop Y, to produce crop Y. Okay. So what we are assuming? We are assuming for crop X we are using X hectare. Okay. So let me write it down. So crop X, so we are using X hectare, and X I can write also X hectare, and for the crop Y it is Y hectare. Okay. So as to maximize the profit, so here our objective is to maximize the profit. So what we need to maximize? Maximize the profit. But what is the profit? So let us go through once more. If you just a minute, let me bring it here. So profit is the 10,500 rupees per hectare from crop X. Now crop X has been allocated for X hectare. X hectare is allocated for crop X. So profit will be 10,500 X, that is coming from the crop X, and similarly 9,000 into Y from the crop Y. So our objective is to find the maximum value of that objective function. So let me write down the objective function here. So maximize Z, and that is equal to 10,500 X 10,500 x plus 9,000 y. Okay, so that is the objective function. Now what are the constraints? So those constraints are coming under subject 2. What is the first constraint? First constraint is the land constraint. X plus y, because the total usage of the land for crop X and Y is at X plus Y, and total land is 50 hectares, so X plus Y is less than equal to 50. And the second constraint is that 20x for usage of the 20 liter of herbicide for crop X, so that is 20x, and in the similar manner 10 liter per hectare for crop Y. So as Y hectare is allocated to produce crop Y, so it will be 10y, 20x plus 10y, and that should be less than equal to 800. I hope you got it. Correct. Now if we simplify this thing, so that we can write is that 2x plus y, 2x plus y is less than equal to 80. So this is the first constraint, x plus y less than equal to 50. This is the second constraint, which is 2x plus y less than equal to 80, and obviously there are non-negative constraints, that is x greater than equal to 0 and y greater than equal to 0. Obviously that number of hectares cannot be negative. All set. That is the formulation of the linear programming problem. After that, what you need to do, dear students, is you need to solve it. So how to solve it graphically? For that we need to draw the coordinate axis. Okay, so let me draw the coordinate axis. Let the formulation be there. So so this is the positive direction of x-axis, this is positive direction of y-axis, this is origin. Now the first straight line is x plus y less than equal to 50. So let us having the scale of 10. So it is 10, then 20, then 30, then 40, then 50. So later we will proceed. First let's do this thing, x by 50 plus. So as you know that in the last example also I said it is better to represent this straight line in the intercept form, x by 50 plus y by 50 equal to 1. So here also we are giving 10, 20, 30, 40, 50. So here is 1 point, here is 1 point. Okay, so let us join in the blue color. So this is the straight line, x by 50 plus y by 50 is equal to 1. Now in the inequation it is x by 50 plus y by 50 less than equal to 1. That means x plus y less than equal to 50. So what we consider? We consider the left hand side portion, right? Left hand side portion we will consider. So this portion we are going to consider. Fine. Now the next one is that 2x plus y less than equal to 80. So let us concentrate on that. So 2x plus y, so if we consider this one, 2x plus y less than equal to 80, that means x by 40 in the intercept form plus y by 80 is equal to 1. Correct. Now x by 40, that we get, this is the 1, and y by 80, so that means we need to increase that scaling also. That is 60, that is 70, and that is 80. So this is another point. So we are going to join these 2 points. So whatever you see, dear students, that I have joined in the green color, that is 2x plus y less than equal to 80. Now here also 2x plus y is less than equal to 80 in the equation. So what we consider, as it is less than equal to, so we consider the left hand side. Okay, so now we need to consider where both left and both green color and blue color are coinciding. Also one thing we need to consider, that x greater than 0, y greater than 0. That means we should not consider anything where x is less than 0 and y is less than 0. So the constants are x greater than equal to 0, y greater than equal to 0. That gives us that whatever we are going to consider is in the first quadrant. So I am marking it in the feasible region, I am marking into the black color. So this part is coming, and after that this part is coming. Correct. So this is whatever I mark in the black color, that border, that is the feasible region. And good point is that it is a bounded region. Good point in the sense that our effort will be little less. In the, unlike the previous example, there the feasible region was unbounded, so we had to do something extra to find the least value, minimum value on the previous example. So now let's give this point as point A, that is coordinate is having 40, 0. Then this point B, which is the intersection of these two straight lines, x plus y equal to 50 and 2x plus y equal to 80. So the coordinates of the intersection of these two straight line is actually x equal to 30 and y equal to 20. So the coordinates will be 30, 20. And then we are getting this is another point, that point C, that coordinate is actually 0, 50. 0, 50, and obviously the origin is having the coordinate 0, 0. So we get O, A, B, C, O is the feasible region, which is a bounded one. So all you need to find, dear students, here is to find the value of the objective function z at all these corner points. That is what is the corner point method. So what we will do here, so we will find the values here. Okay. So corner point and the value of z. So this is corner point and the value of z. What is z here? Let me write down the value of z. 10,500 into x, 10,500 into x plus 9,000 into y. Now what is the first corner point? That is origin. Let me write down origin, and that is 0, 0, and obviously at this point the value of z is 0, and it is also of no usage, because the profit cannot be 0. Any profit can be 0, but in this on some other problem, but in this problem profit cannot be 0. The coordinates of the point A is 40, 0. That means x is equal to 40, y is equal to 0, and with this value, that is x equal to 40 and y equal to 0, the value of z, that is 10,500 into x plus 9,001 into y, that becomes 4,20,000, because 10,500 into 40, that becomes 4,20,000. So that is the profit if we use 40 hectare to to produce crop X and no usage for crop Y. Next one is that B, and that coordinate is 30, 20. And here what is the value of the objective function? 10,500 into 30 plus 9,000 into 20, and if you simplify, you will get this value as 4,95,000. So 4,95,000 is the profit if we use 30 hectare to produce crop X and 20 hectare to produce crop Y. Then next one is coming is that the point C that is having coordinate 0 comma 50. That means 0 comma 50 means x is equal to 0, y equal to 50. That means for crop x, no usage of the land, all 50 hectares is actually used to produce crop y. Now what will be the profit in this case? 10,500 into 0 plus 9,000 into 50. That comes down to 4,50,000. That becomes 4,50,000. Now with all these values, whatever we get, that is 0, 4,20,000, 4,95,000 and 4,50,000, we get that 4 lakh. So let me mark in the red color. 4,95,000 is the maximum. That is the maximum profit, and that profit obtained when we use 30 hectares to produce crop X and 20 hectares to produce crop Y. I hope it is well understood, and we can proceed to the next question, and that will be the last question for today's session. Okay, dear students, so let me bring that one. So this is a manufacturing problem. Okay, so first problem what we discussed is that diet problem. Second problem what we just discussed now is that allocation problem, allocation of land, and this problem what we are going to discuss is that manufacturing problem. Okay. So let me first place it here, and after that we will discuss. Now let me first read out the question. Okay. The question says that a manufacturing company makes two models A and B of a product. Fine. So we get two models. So let me write it down also here. Model A and model B. Okay. So all these are nothing but a kind of a diagrammatically I am going to write down whatever the problem statement I am doing. The tree structure diagram will make easy understanding of the problem. Each piece of model A requires 9 labor hours for fabricating and 1 labor hour for finishing. So 9 labor hours for fabricating. So let me write it down here. Nine labor hours for fabricating. 9 labor hours for fabrication. So I am writing it as fab, and 1 labor hour for finishing. 1 for finishing. FIN I am writing. Okay. Now let me again go through the problem. Each piece of model B requires 12 labor hours for fabricating and 3 labor hours for finishing. So what will happen here? So here we can write is that it is for model B 12 for fabricating. Okay, so it is 12 for fabricating and 3 labor hours for finishing. Done. For fabricating and finishing, the maximum labor hours available are 180 and 30 respectively. That is a constant. Okay, so what I can write is that labor hour for fabricating. Labor hour. Okay, let me write it down. Labor hour for fabricating is, that should be bounded by 180, should be less than equal to 180. Oh, my digital board is not working properly today. 180. And labor hour for finishing is 30. So labor hour for finishing I am just writing FIN is less than equal to 30. Okay, so that is the one. For fabricating, finishing, the maximum labor hours 180 and 30. For fabricating and finishing, the maximum labor hours available are 180 and 30 respectively. You see, dear students, left hand side in the red color whatever is written is the English statement, and right hand side in the green color whatever I am doing in the mathematical expression. The company makes a profit of rupees 8,000 on each piece of model A. So the profit here comes is that, if I can write, so from here the profit is 8,000 per per piece of model A, and for model B it is actually 12,000. So here it is 12,000, correct? So the company makes a profit of 8,000 on each piece of model A and rupees 12,000 on each piece of model B. How many pieces of model A and model B should be manufactured per week to realize a maximum profit? Again, in the similar manner, let us assume that model A has to be manufactured X units, X pieces actually, in context to the problem, X pieces of model A and Y pieces of model B per week. Then what will be our objective function? Our objective function will be 8,000x. Why? Because per piece of model A the profit is 8,000 rupees. So for X pieces of model A the profit will be 8,000x. Similarly, the profit from the model B will be 12,000y. So what we need to do is that we need to maximize Z, the objective function, that is equal to 8,000x, let me write properly, 8,000x plus 12,000y, that is the objective function. And what is the subject to? That subject to the constraint. So subject to the first constraint. What is the first constraint? Is that the labor hour for fabricating is 180, maximum is 180. So we know the labor hour for X pieces of model A, it will be 9x, because we know that labor hour for per piece of model A is fabrication labor hour per piece of model A is 9. So subject to it is 9x plus 12y, okay, is less than equal to 180. So we can simplify by dividing both sides by 3. So it becomes 3x plus 4y, 3x plus 4y is less than equal to 60. That is the first constraint. And the second constraint is that the labor hour for finishing is maximum 30. So in the similar manner, for manufacturing of the per piece of model A, the finishing labor hour is 1. So for x units it will be 1 into x, that is x. Similar manner, plus x plus 3y, that should be less than equal to 30. That is the second constraint. And obviously the non-negative constraints are x greater than equal to 0 and y greater than equal to 0. These are the non-negative constraints. All you need to do is that we are now much experienced that how to solve it. Simple thing, this is the formulation is done. Now what we need to do, we need to plot the straight lines in the graphical manner. Okay, so let me do it here. So So this is origin, this is positive direction of x-axis, this is positive direction of y-axis. The first straight line is that 3x plus 4y is less than equal to 60. Okay, so that means what we can write is that x by 20 plus y by 15 is less than equal to 1. So what I wanted to mean, so this one, if we represent in the intercept form, that becomes x by 20 plus y by 15 is equal to 1. So if we make a scale of 10, so this is 10, this is 20, this is 30, this is 40. Okay, so x by 20, so this is 20, and y by 15. So if we make the same scale in along y-axis, 10, 20, 30, and so on. So 15 will be somewhere here. So let's join these two. Okay, and it is less than equal to 60. So that means what? We will consider the left hand side. Correct. Then the first straight line we have done. Next one is that x plus 3y less than equal to 30. X plus 3y less than equal to 30. Let me use a different ring, suppose green color. So that implies x by 30 plus y by 10 is equal to 1. So x by 30, 30 is here, and y by 10, 10 is here. So we will join these two, and it is less than equal to this. So that means this comes in this way. Okay. Now we need to consider the feasible region as the region where the red and the green line overlap, and also it is in the first quadrant because of the non-negative constant x greater than equal to 0, y greater than equal to 0. So that means if I mark the feasible region in the black color, so it will be, this is the feasible region, correct? So if we consider, let me move it up a little bit. So if we consider, this is the origin having coordinate 0, 0. If we consider this point as point A, its coordinate is 20, 0. Now this point, which is the intersection of these two straight lines, that is 3x plus 4y equal to 60 and x plus 3y equal to 30, if we consider this coordinate as point B, and if we solve these two straight lines, that is two linear equations, the first one is 3x plus 4y equal to 60, and second one is that x plus 3y equal to 30, we will get the coordinates at 6, 8. Okay, and then we get the point C. So this is the point C, and its coordinate will be 0, 10. Correct. So now using the corner point method, we need to find the value of the objective function at all these 4 points, 0, 0, that is the origin, A 20, 0, B 6, not 6, 8, sorry. If we solve, I made a mistake here, dear students. If we solve that, these two straight line, that is x plus 3y equal to 30 and 3x plus 4y equal to 60, we get the value of x is equal to 12 and y equal to 6. So coordinate of the point B will be 12, 6. Sorry, whatever I said earlier was wrong. Now let's come to find the objective value of the objective function using leveraging corner point method. Okay. So this is the corner point, and this is the objective function, value of the objective function. So I am writing here corner points. So the first point is the origin, which is 0 comma 0. What will be the value of the objective function? What is the objective function, by the way? Objective function is 8000x plus 12,000y. That value will be, so here we are writing the value of z, so it will be 0 obviously. Next coordinate point is that the point A is having coordinate 20 comma 0. So point A having coordinates 20 comma 0, that means x equal to 20 and y equal to 0, and for these values of x equal to 20 and y equal to 0, the value of the objective function z is 8000 into 20 plus 12,000 into 0. So that becomes 1,60,000. 1,60,000. Okay, done. Next one is that the point B. Okay, at the point B, the coordinate is 12 comma 6. That means x is equal to 12, y equal to 6, and at that values of x equal to 12 and y equal to 6, the value of the objective function 8000 into x plus 12,000 into y, that is 8000 into 12 plus 12,000 into 6, that will become 1,68,000. Okay, 1,68,000. Done. And finally coming the point C is having coordinates 0 comma 10. The point C is having coordinates 0 comma 10, and at that particular point the value of the objective function is 8000 into 0 plus 12,000 into 10, that becomes 1,20,000. Okay, so this is done, and we need to find the maximum value of the objective function. That means the maximum value here we get is that 1,68,000. So that is the maximum value, and here as the feasible region is a bounded one, we no need to do anything extra. So the answer to this question is that the maximum profit is rupees 1,68,000, and that profit is obtained when we produce 12 pieces of model A and 6 pieces of model B per week, and in that case the per week the maximum profit will be 1,68,000. So dear students, with this note let me conclude the class here. All you need to do is that log into the online test platform at konarkclasses.com and make some relevant practices. Okay, that's it. This will make your preparation absolutely rock solid. No other extra problem is required to solve as long as the linear programming problem is concerned. So if you do not have any questions, so let me conclude the session here, dear students. Thank you very much.
Yes, sir.